exciting and difficult mission.
What really excites me about this mission is the fact that Titan has all of the key ingredients needed for life: liquid water and liquid methane.
Imagine if Earth was ice rocks made of frozen water and our rivers flowing with methane. Ladies and gentlemen, it's not just a figment of your imagination. That's Titan, Saturn's mysterious moon with its own atmosphere. For years, NASA has been planning to uncover its secrets with a powerful drone. But just when things were getting closer, the agency came face to face with a stumbling block. Now set to jet off in 2028, lingering questions remain. Why exactly is NASA now fixated on a moon so far away? In this video, we'll uncover the secrets of NASA's ambitious Dragonfly mission to Titan, as well as the surprises this Earth-like moon has for us. You don't want to miss this. As far as we know, Earth is the only planet with life. It has everything we need to survive, like water, food, warmth, a layer to shield us from deadly radiation, and much more. However, if space is indeed endless, would it be far-fetched to think there's another body out there that supports life? Scientists have been searching for other habitable locations across the universe, and apart from the Red Planet and Mars, they believe Saturn's moon and Titan could be humanity's salvation.
Titan is a really fascinating place. It's the only moon in our solar system that has a thick atmosphere. It's actually thicker than Earth's atmosphere.
For years, NASA had been planning to explore the celestial body, but just when we thought that the maiden mission would start in 2027, the agency just announced that it'd be postponed until 2028, citing budgetary issues surrounding the project. According to an official release from Nicola Fox, Associate Administrator of NASA's Science Mission Directorate, the Dragonfly project will undergo reconsideration in the upcoming spring following NASA's financial year 2025 budget proposal. And if everything goes as planned, the launch of the Dragonfly will take place in 2028. And speaking of which, how about we finally talk about the elephant in the room? Or should we say the Dragonfly? As funny as the name seems, the Dragonfly is actually a nuclear-powered car-sized drone that is designed to investigate the complex chemistry that is the precursor to life. Notably, it stands as the only NASA mission planned to land on the surface of an ocean moon, and once the drone lands on Titan, it will immediately delve into conditions that could suggest habitability, examining prebiotic chemistry and seeking indications of water or hydrocarbon-based life.
This picture, combined with this picture, means that this is the first observation of a liquid, a lake, on the surface of a body other than the Earth.
Reports suggest the drone will be equipped with cameras, sensors, and samplers designed to analyze Titan's dense, nitrogen-rich atmosphere, investigate the formation of organic compounds, and assess whether Saturn's moon currently supports life or has ever done so. All in all, this mission is expected to span nearly 3 years. On paper, everything looks pretty good, but skeptics actually doubt that the Dragonfly will be able to bear Titan's unique atmosphere, which has a very high ratio of atmospheric density to surface gravity. This characteristic drastically decreases the wingspan required for an aircraft to sustain lift, to the point that an average human could put on wings and effortlessly fly through Titan's atmosphere while wearing a spacesuit.
It's a combination of two things. One thing is that the gravity is pretty low on Titan. It's about 1/7 of the gravity on Earth, so that helps. Because you don't need as much, energy to get off of the ground.
In line with the extreme engineering challenges of this space mission, the team is leaving no stone unturned in developing the spacecraft. They've carried out several analog tests on Earth to this end, and one example is testing the drone's guidance, navigation, and control systems in California deserts, which mimic Titan's sandy terrain. Secondly, test campaigns at the NASA Langley Research Center in Hampton, Virginia, have focused on evaluating the aerodynamic performance of the vehicle under harsh and unique conditions. This is to anticipate the challenges Dragonfly will encounter during different stages of the mission. Finally, the Dragonfly Thermal Development Test Module, DTM, underwent atmospheric pressure testing in the APL's new 3,000 cubic foot Titan chamber. This state-of-the-art chamber utilizes 200 gallons of liquid nitrogen per hour to replicate the temperature and air pressure conditions on Titan continuously for a 24-hour period. According to Ken Hibbard, Dragonfly Mission Systems Engineer at Johns Hopkins Applied Physics Laboratory, the aforementioned tests all contribute valuable data to the Dragonfly Titan simulations and performance predictions under the difficult conditions on Titan. Questions have also been raised concerning how Titan will be able to land on Titan, but nevertheless, that issue might have been solved already. In one of the latest tests, the Dragonfly team set up a half-scale lander model of the spacecraft to test the drone's descent on Titan and its flight over the surface. At this point, you're probably wondering why NASA is so interested in sending Dragonfly to Titan, aren't you? After all, Mars has been the object of our desires for years, and we haven't even conquered it yet.
Will enable people to move to Mars for approximately $500,000.
$500,000?
Yeah. And you can get a free return ticket with that, by the way.
A journey all the way to Saturn seems a bit counterintuitive and a waste of resources, but the reason will surprise you. For starters, Titan is unique. It is the only moon in our solar system with a dense atmosphere, approximately 4 times as thick as Earth's. The value of an atmosphere to a celestial body cannot be overstated. Without it, Earth will have no protection from the sun's radiation and no means to distribute gases that are crucial for sustaining life. We wouldn't even have a regulated temperature. Additionally, the terrain on Titan is eerily similar to that of Earth. According to NASA, Titan is carved by huge flowing rivers and lakes that hold methane instead of water, as well as rocks that look like ours, but are made of water ice that stays frozen because of the celestial body's cold weather. There are also amazing energy resources on Titan that humans could use, like wind, chemicals, and hydropower. Electric power on Titan could even be generated through chemical power plants by a process known as hydrogenation, where oxygen is not freely available. Another potential method involves turbines in the expansive methane seas, such as Kraken Mare, where the tidal pull of Saturn induces up to a meter of tidal change each Titan day. Researchers also believe solar and nuclear power might be feasible on Titan. Finally, using the Atacama Large Millimeter Submillimeter Array, ALMA, in Chile, scientists detected the presence of C3H2 in Titan's atmosphere. The carbon-based molecule, not found in any other atmosphere, is seen as a potential precursor to more complex compounds that might play a role in developing or supporting potential life on Saturn's moon. All of these findings suggest the possibility that Titan might be harboring intriguing secrets related to alien life forms. Alas, possibilities and facts are two completely different things. As it is, Titan is still completely unsuitable for terrestrial life. The frigid temperatures of -180 degrees Celsius on Titan would freeze any water present, and since all life on Earth is based on water, this poses a challenge. Additionally, although the atmospheric pressure on Titan is moderate, there is no oxygen in it. As a result, humans would have to dwell in an enclosed habitat that could be warmed up and supplied with oxygen, perhaps manufactured from Titan's frozen water. Even if we were to achieve this technical achievement, would we be sharing the planet with local life forms as we do on Earth?
Lakes of liquid methane, because it's so cold. And the methane behaves exactly like water on Earth. So you get rain, methane rain, you get methane snow, methane ice, and lakes of methane. There's a lake there which is as large as Lake Superior.
Methane, which is essentially...
Scientists have speculated that life on Titan might be based not on liquid water, but on liquid hydrocarbons like methane or ethane, which are abundant on the moon. We're yet to see any convincing evidence for life on Titan, and it's hard to fathom how life might overcome the difficulties of operating at such low temperatures where even chemical reactions get very slow. With the aforementioned issues that await humanity on Titan, exploring the moon itself to witness its amazing possibilities is far more realistic than living on it, or even finding life itself. But unfortunately, even getting there is tough. Unmanned satellites have taken years to reach the distant moon, and currently, human transportation to such distances is beyond our technological capabilities. And even if it wasn't, the surface gravity of Titan is about 0.138 g, which is slightly less than that of our moon. Handling the long-term effects of low gravity on human health would pose a substantial challenge for the prolonged occupation of Titan, even more so than on Mars. These effects, which include symptoms like loss of bone density, loss of muscle density, and a weakened immune system, are still actively studied and represent critical considerations for any potential future missions. That said, we have a lot to gain should we overcome the challenges. American aerospace engineer and author Robert Zubrin identified Saturn as the most important and valuable of the 4 gas giants in the solar system for its relative proximity, low radiation, and excellent system of moons. He even boldly claimed that Titan is the most hospitable extraterrestrial world within our solar system for human colonization, despite the fact that Mars is at a viable distance for human space travel, roughly around 7 months. Its living conditions are far from ideal. The planet is bombarded with dangerous UV radiation, and its magnetosphere is feeble, providing little protection from space radiation or the sun's incoming charged particles. And as if that wasn't enough, there simply isn't enough oxygen for humans to breathe on Mars. The planet's surface is predominantly composed of iron dust and rocks, contributing to its distinctive red and rusty color. That said, how excited are you about NASA's ambitious expedition to Titan in 2028? Also, while it's undeniable that it will take a lot of work, do you think humans may just live there in the foreseeable future? See you in the comments section below, and don't forget to like, subscribe, and hit the notification bell so you don't miss out on any new content.